So today on Data Radicals, we have Zhamak Deghani, who is a consultant, but that seems to me to take away from the contribution she's made to the data space because she is a thinker, a thought leader in the most fundamental sense, and somebody who is associated with a term that is super popular and maybe the most popular term in data right now, which is data mesh. So, Zhamak, welcome to Data Radicals. It's a pleasure to have you on.
Hi, Satya. Thank you for having me and thank you for the kind introduction.
Let's get into it. What is you're associated with the data mesh? What is a data mesh?
Right. I read the one-line definition that I have. It may not be the best one. I may have to double click into it, but let me read it out. Data mesh is a decentralized socio-technical approach to share, access, manage analytical data in complex and large-scale environments, whether it's within an organization or across organizations. So that's the one-line definition of what it is, and it's a mouthful.
It is, but I think the key word is decentralization. Why do you need a decentralized approach? What is it that inspired you to think about a decentralized approach
Yeah.
and proposing one?
Yeah, absolutely. I think the discord between real world scale of complexity, inherent complexity of organizations and business, right? Your problem space that you want to get meaning out of data, find patterns within it, analyze it in a very, very complex world that is constantly changing. The sources can vary, the data itself can vary. The discord between that and the solutions that we had put in place to solve that problem, right? I think the observations that I early days when I entered the world of data I had were around kind of the repeated patterns and the stories that I was hearing from clients that were technologically fairly advanced, as in they had invested in their, multiple revisions of like the Hadoop infrastructure, they had migrated into the cloud data infrastructure. But the stories were the same, the problems were the same. They had invested in yet another data platform, app dev teams, or let's say those cross-functional domain teams that were building the business functions, were kind of oblivious to data. Data engineers are stuck in the middle, where under sheer pressure just move data from one bucket to another bucket without really understanding the data itself or understanding how the data is going to get used. And the data users or analysts or data scientists that we're talking to, working with, they were kind of frustrated because they were stuck without still not having access to the right trustworthy data for the ultimate value that they were intending to deliver. And the executives were burning money without showing value, so changing jobs ultimately. So and everybody was looking for another silver bullet. So I think seeing the real world problems made me curious about the data space, scratching the surface and seeing the discord between the reality of the complex world we live in with data and then the solutions that weren't really up to the task for dealing with that complexity got me kind of to look further for a solution. And then inspiration, I think, came from my experience with large scale kind of microservices and distributed systems in the world of functional, I guess, systems, and try to kind of apply those techniques and learnings into the world of data. And that inspired, I guess, data mesh as a solution.
People who are app developers are often oblivious to the fact that they're developing data. Talk a little bit about that, because I think that may be one of the root causes, or at least to me, is one of the root causes to the problems.
Absolutely, and I don't blame the developers. So let's just unpack that a little bit. The current state of affairs is that developers are building applications to satisfy a certain function of the business, and many of those functions today are built without being informed about the data or augmented by intelligence or ML, informed by the data. So application developers saying, I'm building a GUI, I'm building an e-commerce application, whatever, I'm building a microservice. My relationship to the data is to store the current state of the data to satisfy my application's behavior and optimally store that, so I have a really, fast read for my application refreshing the screen, or I have transactional storage of the data for this particular transaction of the payment, or purchase that got performed. So the data is modeled and hidden away behind the application, optimized for a particular feature. And the more we decentralize kind of the application world with microservices type architectures, the more fragmented that data becomes, because that data is only keeping the current state of that application. And that's perfectly fine, right? From an application developer. On the other hand, we said, okay, actually, we need to have this other team, other parts of organization dealing with gathering insights, training machine learning models so that we can intelligently act upon some of these transactions and respond and optimize, personalize the user's behavior, personalize for the user behavior, and so on. But that is a problem that a different team needs to solve, so that we have to get this data somehow extracted. I feel like that extraction, it's an insult almost. It's such a pathological coupling we create. Anyway, extracted from these application databases and then moved some other place and then modeled other place and then enriched some, with metadata so that somebody else can solve the problem. So the application developer has no relationship with that world. And then when sometimes that world comes back as, now we've built an ML model that you can evoke as a microservice to get the best, I don't know, recommendation, or as a database to show the proposed product catalog, they just see that as a yet another service somebody else is providing them. So I think there are two problems, that the points of, I guess, friction or the tension that really doesn't let the application developer care about the data is, one, they're so far away from intelligent aspects of their application. They're not, posed with the problem of, actually, your application need to be intelligently augmented with ML, with insights, with analytics, so that they have an intrinsic motivation to care about the data, to be modeled in a way that not only support the application, but also with models that supports the insights and, the analytical view of the world. So that's one problem. And then the other problem is that the people that are responsible for that insight gathering are just so far away. They're siloed somewhere else. So you don't have that natural empathy even built into the ecosystem.
My background is in economics, and I guess I always think about it as an externality. So there's this concept of, like, you have a car, and the car is driving along and it creates carbon exhaust, and and the carbon exhaust has impact on the environment. It's not like the car is moving,
Yeah.
in a vacuum, and therefore this carbon, like, it creates its own economic exhaust and all these bad things, and in some cases the externalities can be good. But I think of data as an externality. Like, the app developer is just trying to drive their car, and they don't really think about the fact that there is all of this information that's being produced that somebody can do something with. And in many cases, I don't even think they know what could be done. They don't have the
Yeah.
imagination or the intention. So it's hard for me. It's like almost like asking a contractor or a plumber to know how somebody wants to use a steam bath. Like, those
Mm.
are, you can, I mean, that's a simple case, but I think a lot of software development is so complicated and it's hard to know. So I don't know. I guess my thought is, I've observed the same thing, but I don't know if it's easy to tell. I think it's hard to tell somebody who's developing an application to think about how to measure it.
Sure. And I think I love the car analogy and externalizing the cost of, running that car to somebody else. I think you're right. But if we said that, if the app developer is the car manufacturer or car builder, you would say your car is not only running fast and smooth and, delights the driver, but it's also should be a sustainable car. So you've got to build that functionality of sustainability into the application for the app developer have any motivation. And then it's not really that particular app developer that is optimizing the driving experience. Perhaps it's an augmented team. That's why we have, in data mesh, you have kind of these cross-functional teams with data embedded, to say, actually, there is a part of this team that cares about the sustainability, which then requires data not only from the car being emitted, emitting data, but also the rest of the organization. So I think going to Maslow's like hierarchy of needs. We've got to put some inspiration in terms of implement the need for data back into the application, and that probably is the next generation set of applications we're building, not today's generation of applications. Today's generation of applications solve a lot of problems with human reasoning and logic, and not data driven exploration of patterns.
Yeah, that to me sounds right. Like it that's really a that's like just totally learned something. But I do think that analytics, data science, the consumers of the data have to be a first class citizen in the design process for the software day one.
Absolutely.
And that won't necessarily solve all the problems because maybe they'll think through the first order analytical problems, but it's almost like having an environmental engineer consult on building a house, right? Like that would
Yeah,
seem to
totally.
be part of the design process that doesn't really exist. So then you went from there into say, well, there's this new possibility. So then from there it goes to that there's that software developer, and then of course the other old alternative architecture is this data engineer who's literally moving up around data as if you were moving around boxes in a warehouse, blind to what's inside of the box. um, and then of course there's the analyst. And I guess there's this new theoretical role, that's like kind of this analytical engineer where the idea is the analytics person becomes the data engineer. Does that factor into the thinking of how you consider the mesh or?
Yeah, I think with the as you described, the current organizational structure, the roles that we have defined, stems from this pipeline architecture, this manufacturing mindset that you data is in the source in a format that nobody can use, and then there are people along the way that take this data through the manufacturing pipeline to pop out meaningful insights, ML models trained on the other end. And along the way, we have these steps of cleansing and enriching and a bunch of ETL pipelines, the storing, modeling, then overlaying kind of metadata, governance, and then somebody along, that the ML engineers pick that up, and then yet again they transform it, put it into their future stores, or analysts, putting the BI databases so they can put reports on it. So you've got this kind of manufacturing mindset, and that every time we hop one of these steps, there is a there's a handshake. There is a loss of either context or a new skill that needs to be developed. And then we realize that the gap between the engineer on the like pure software engineer on the left and the pure analyst on the right, there is a huge gap. And then we create these intermediary roles, analyst engineers and ML engineers, to kind of fill this long gap. What data mesh does tries to shorten this gap as much as possible and bring what considered valuable consumable data as close to its point of origin. And point of origin could be an app, and point of origin could be a completely new set of data sets, created, but really close that consumer provider relationship so they can talk to each other directly. And then following that line, a lot of those intermediary roles go away and they get embedded into the boundary of this concept of kind of domain oriented data product team that is doing all of the massaging and whatever needs to happen within the boundary of domain to present the data in a way that a pure analyst can directly use it. So maybe the sum of those analyst engineers, ML engineers, those roles get embedded, and I just simplify them, and I would just say they become data product developers in a way. Their job is not just do one step of the transformation or one step of the translation. Their job is directly talk to the consumers of the data. And you see something really important that early in the conversation, that the analyst data scientists should be the first class customers or users of the data. So then they really get embedded into the domains and focusing on the data in a way, presenting the data, sharing the data in a way that an analyst and data science can directly use it and get value from it from without yet another, movement or step in the process.
Yeah, it's such an interesting insight. And I guess then in that world where there are data product developers, the skills required by that individual dictate what data products they can develop, or the data products that they're
Yeah.
trying to develop dictate the skills that are needed, maybe is the other way to say it. And so if you need to know, clustering, or you need to understand neural nets, those are things that you can have as skills depending on the problem that you're trying to solve and the product that you're ultimately trying to develop.
Absolutely. And I think this is a kind of a missed point in a lot of the conversations. What data mesh tries to create is some sort of a meta architecture for data sharing, not pure data sharing, but data as a product sharing and connecting these data products to create higher value products. So a scale out network based value creation model that is purely about data sharing. But as you said, some of those data products could have simple transformation. Let's say I'm getting customer information from a variety of sources of applications because I've got a call center and an e-commerce system and a bunch of other systems that generates information about the customer. And I want to have a customer representation, a data product, which by the way I do not recommend, but let's go with that example. So my transformation to provide analytical data and a historical view of customer information across across all of my channels, across all of my regions and touch points with the customer becomes perhaps a relatively easy data processing, like a typical pipeline processing. Conversely, as you mentioned, if a data product is now classification of the customers so that we can have different marketing strategy for them, profiling of the customers, that data product embeds an ML model inferring information and patterns from classification from this other data product.
So let's go back to the definition of data mesh, because we talked about this idea of decentralization. We talked about, but there were other words in your definition, socio-technical approach. And I didn't write down the notes exactly what the definition is, but I'd love to unpack those pieces as well, because I think there's a lot of instruction in the follow-on portions of the definition. So maybe let's talk
Sure.
about what a socio-technical approach is, because that's not something that I heard of prior to.
Sure. And some people that might be listening said, no, it should be techno-social and whatever slant of it. So what I meant, and I'm sorry that I had to pick one of the two, but
I really hope there isn't anybody who's listening that's saying that, but let's go with
oh,
that.
they are. I have been told that you've got to rotate this because it's like techno-social. Well, it concerns both the organizational design, decisions, so organizational structure, roles, and also technical solutions. So excellence of or that the adequacy of the technical solutions as well as the social structure are both part of the solutions. In fact, I started just as an architecture. Like my first writings were more focused on the architecture, and then I realized I cannot just talk about architecture. This goes beyond that. So there are I guess in the first principles of data mesh that focus on the architecture technology and some that on the people side. For example, the domain oriented ownership of the data as a product itself has a lot of social, I guess, design concerns there. How you organize your people and their responsibility around the data in a decentralized fashion. Your the federated kind of computational governance, the federated part of it is again has a social element that your governance shifts left, gets embedded into those domains, and a lot of those not all but many of the governance concerns we have today get again decentralized into the domains. So that federated aspect, again, organizational structure. On the technical side, I think it's kind of obvious, even though it's technology agnostic, but the architecture and the choice of technology has to fit this I guess social structure that we're setting up. And that the self-serve platform part of it, the architecture of the data product, the architecture around the data sharing, that's the technical part of it.
Decentralized architectures talk a lot about sort of this like shared nothing concept. Is anything shared? I mean, like is, and if there are things that are shared in the data mesh framework, what would they be?
Sure. Yeah. So for the mesh to work, the standards, the interoperability standards are shared, right? So the data sharing standards that we have to put in place so that we can both at three layers, the layer of both just simply communication. How do I create a data product that is consuming actually data from five other upstream data products and is computing and is creating a new one? How do these things connect with each other? So input, output, egress type of relationship that needs a standard that is shared across all of the data products. And then, so as the data modeling itself, how do you model independent nodes? How do I model order that a customer put in one data product versus the customer call with a call center in a way that I know it's the same customer across two independent nodes? So the semantic modeling with the semantic kind of linking of these data products is another shared concept. And there's many cross-functional, I think, concerns that can fit into the standards to get a distributed system work. And then the infrastructure as well. We don't really want to be in a situation that every team, every domain team is spending, really valuable resources and people's time and effort on building full stack infrastructure. So the infrastructure is shared. And I sometimes think that centralization, decentralization are really two sides, the yins and yangs that need to exist to actually have a functioning system. So there are aspects that need to be centralized and shared. um, there there are challenges to address to make sure those centralized pieces of the infrastructure don't become bottlenecks. But put that aside, I mean, you want to share technology, so you have some sort of economy of scale. So I think these two are certainly shared.
What do you think are the key enabling technologies for the data mesh? Like, what are the standard ingredients that an org unit would need to have in place in order to get a data mesh going?
To get data mesh going, I think that if I categorize technology into two general buckets, the bucket that enables implementation inside each data product, right? You would need transformation, you would need storage, and you need
Yeah.
these in a way that can have the diversity of transformation implemented and so on. I think I put that bucket aside. I think we need that technology, but we also need that technology today for lake or warehouse. They may have a slightly different nature or reconfigured differently, but we need that. So let's put the technology that implements what's inside the node aside. I think the pieces of technology that are really critical and perhaps missing are the pieces that enable interconnectivity between the nodes. It really enable um, running these analytical workloads, like generate a report or keep training your machine learning model without data movement, like in a distributed fashion over the mesh. And for that to work, I think again, if we work backward and say, okay, what does that look like? I think one piece of it again is the standards, the language with which we would express those distributed computational workloads, the APIs on each node that enable the the response, the request response for those. So again, I'm putting my distributed kind of system engineer hat answering these questions.
Mm-hmm.
So I think I would think about discoverable, like the protocols as really the essential pieces. The protocols are around discovery, addressability, data sharing, distributed analytical computation. I mean, we have distributed or federated SQL, but what's the next phase? What's beyond that? Um, I think those are the really key pieces that are missing. And then the second, as part of those protocols, again, if you unpack the protocols, I think that analytical data need to have a temporal, by definition is a temporal data, and if it's distributed, it kind of needs to be immutable, because if you have a stateful distributed system, it's a disaster. So then then kind of the next level protocol is that what is a sensible, easy to use, high level kind of temporal representation of analytical data that enables kind of streaming like processing. I'm not talking about event processing, but even if it's the windows of time that we analyze, what does that protocol look like? So yeah, long answer in short, protocols, data protocols, data contracts.
There's like the data warehouse and the centralization idea, and then there's this idea of sort of distributed products. And like, I don't think you're saying, oh, well, there's never going to be a warehouse where information is centralized. Like, some subset of information is centralized. Like, that will
Yeah,
exist, but but perhaps give up the ghost around there being a singularity around truth, or that everything is going to
absolutely.
be centralized. And I think that to me is like the key aha, the insight, because if you let go of the idea that everything needs to be centralized in your thinking, it just frees you up to be a lot more dynamic in how you treat data and who can own it and who can use it. And that's really empowering. And obviously all the implications of data being the consumers of data being close to the design, I think, are obviously super super useful and interesting. Have you, since you've written the paper, have there been major evolutions in your thinking?
I think I had to introduce the fourth principle since the first paper. So that was a big change because I had it as one little line item, standards somewhere. And then I realized the governance, sorry, the computational federated governance had to be introduced as its own pillar for the pillars to be complementary and complete. So I think that was one big mutation that happened. I intentionally stayed away from practices and technical implementations and designs early on because I knew that would keep changing forever and improving for good reason. I stayed to the first principles, and I think those first principles haven't changed. My own personal thinking around the design is crystallizing over time. Starts with fuzzy and then just dig into the details, and with each iteration of implementation, the design gets a little more crystallized, but still a lot of fuzzy areas. Like, I mean, what the heck is this distributed analytical data sharing that we're talking about API? So, um, yeah, so I think incremental just improvement to practices, but the first principles pretty much stayed the same.
There's a lot of concepts in data, but one in particular that I feel constantly gets confused with data mesh is data fabric. Like, in fact, I think naively people are like, oh yeah, I have a data mesh, data fabric. They're all the same thing. Like, you know, uh, do you get that? And is that something you've heard before? And I guess, and can you help us kind of describe the differences between these two things?
So I think there are similarities and differences. So data fabric, the way I understand it, going back to the origin of it, really started as a system to allow access data at a physical level across boundaries of different platforms. So it was kind of the NetApps of the world, and systems that really allowed create they created a layer to for you to access data on hybrid cloud environment. It was kind of a cloud migration strategy for many. So again, it's a physical layer concern versus data mesh that is a logical layer concern. And then fast forward, kind of Gartner started overlaying on top of that idea and saying, well, what if we just assume data can be anywhere it is, if there's a physical layer that gives you access to the data, and let's just start overlaying magical AI, intelligence, metadata to then make meaning out of this data, right? So pretty much keep doing whatever you are doing, app developers, put the data wherever it is, and then someone else at some other later point with machine learning, drives meaning out of this data that you have. So data mesh, so on the first front, it's not a physical layer, it's a logical layer concern. And philosophically, I think is in conflict with this idea that keep doing whatever you want to do, unintentionally share data, and then some magical AI will make sense out of it. In fact, data mesh, I mean, my kind of value system puts responsibility on humans and saying, in fact, let's get the human in the loop to intentionally build data as a product, to design and emit the right metadata to serve meaningful data. And yes, if you want to sprinkle intelligence on top and have this next generation, I don't know, data catalogs or whatever it is that gives you more meaning out of that, so be it. But don't build a system that is garbage in intelligent on top of it and then garbage out. That's I don't know, apocalyptically dark world. So I think it depends on what you mean really by data fabric. Do you mean the system of data integration across multiple environments? And I think that could be absolutely part of data mesh. Or do we mean this other philosophy of share data as is and then kind of overlay that with intelligence for it to be meaningful? And I think that perhaps there is a conflict in philosophy around that.
Yeah, that the AI pixie dust will solve all your problems. Yeah.
AI and metadata, Pixie does. Yeah.
Yeah. Well, I mean, you have. I mean, I think the metadata has to exist in the mesh framework and
Yeah,
does exist in the fabric framework. I think it just is a question of like how you generate these things and how you generate
exactly.
it and how you actually produce it. And I think you're basically saying, look, as a product owner, that's your job.
Yeah.
That's your job. So, I guess now looking forward a little bit, are you spending the majority or the vast majority of your time talking about data mesh? Like, is this where you spend your time, and is it more on? I mean, are you in a place where you're spending more time explaining the concepts? Or are you in a place where you're spending more time implementing the concept, or is it a mix? And how have you seen that change over the last couple of years?
Yeah. So I think I'm still talking about it a lot. But the talking is based on the experience of seeing different patterns and has moved from what is data mesh to how to do data mesh and how to evaluate technology so that I can do data mesh right. What are the guidelines? So it's moving from what to how and how to do it right. And I hope that I at least stay close enough. And again, I'm not a developer on one implementation, but I do have touch base with multiple development teams that are implementing it globally. So I hope I keep that connection so I can get the feedback coming in. What I hope to happen in the next few years is to kind of shift focus a little bit more to how to enable it, right? What is missing and contribute to the standards and contribute to the technology to fill the gap.
Yeah, yeah, I think that's right. I mean, I think that that's a. I mean, look, I'm right there with you. I think there's a lot to do to enable these architectures and, well, not architectures, these approaches, so that people have a roadmap to get to this end state faster, um, which is just, I guess, the fun of all of our jobs and all of our work. Any warnings, common pitfalls, risks? I'm interested. If I were interested in data mesh and just hearing this podcast for the first time, what would you have me walk away with?
Mm.
And
Yeah, I think have a big, deep introspective as is this the right thing for me and is this the right moment in time? Don't assume that you can just buy it and over time you get to all the outcome that you want. So assessing a deep self-assessment of should I make a move toward data mesh now and what that entails for me and if there are risks along the way that is applicable to my unique situation, what are those risks for me to mitigate? So that's self-assessment. And in fact, I put that in the book because I had to cover the organizational side of it. And I thought the first step is, shall I do that now? That would be one thing I would say for people to take away. And the other is go beyond whether you're a researcher trying to understand or you're a vendor trying to implement or organization trying to adopt, go beyond the hype, really like understand the motivation behind it. Do those motivation apply to me? And then assess your technology choices, solutions that you're building, um, for a long run, based on a long term kind of transformation, not based on a short term. I'm just going to plug this in and bam, I've got data mesh. So really treat it as a transformation. And the last part I would say is that socio-technical we talked about. um, organizational design is absolutely crucial, because we could have, the best organizational structure and, sorry, best architecture, distributed architecture and mesh, but yet a centralized data organization, and that architecture very quickly devolves, or that solution very quickly devolves to mimic the organizational structure, right? Conway's law. So even if you have to do an inverse kind of Conway's maneuver of reshuffling your organization, even with a monolithic architecture, that would enforce changing and decoupling your architecture, because you mentioned earlier that that becomes a bottleneck. So don't forget the organizational part very, very early.
Zhamak, it was such a pleasure to meet you and to have this
Same here.
conversation. So great. And we'll look forward to having you back on at some point in the future. But thank you for taking the time.
Thank you for lending your platform and getting my voice heard. It was a pleasure.